Welcome to this video. We'll talk about our work, Tree Structure of Collective Attention Network, Revisiting the Problem of Dropout. With the increasing development of MOOCs, it attracts thousands of people to learn online. However, there are some people leave halfway, and the dropout rate are particularly high. It can't help but cause people to think, why did they leave? It was first treated as a sign of deficient quality, but later as an explicit expression for an individual's choice. This later counter-argument highlights the importance of focusing on how dropouts learn in MOOCs, and in what ways the learning design of MOOCs facilitates their learning. In some work, the behavior data of dropouts are less considered, and it often removed as outliers in traditional statistical analysis. In our work, we followed the idea of collective attention and regarded the learner's clickstream data as an embodiment of learners' continuous attention flow to explore the learning pattern of dropouts. That is, to explore how do they manage and allocate their attention in online learning. The collective attention network is built from the transposition of traditional social network. Unlike the structure of social network, it uses node to represent the learning resources, and the link to represent the learner's sequential visits across the learning resource. At the collective level, the large body of learners' sequential visits resembles the flux of attention flowing in and out of the learning resources. Introduction to Psychology, from a Chinese MOOC platform, was selected as the case to study. It offered 70 learning resources within 13 units. 9,508 learners participated in the course. 5,237 learners accessed the course via mobile devices, such as mobile phone and tablet. The rest 4,271 learners visit via web client. But due to the incomplete records of behavior data via mobile devices, we just focus on the 4,271 learners' behavior data. Among these learners, 2,110 learners' information of registration and exam are deficient. In the rest 2,161 learners, 1,892 learners were dropped out. The dropout rate are nearly 88. At last, 1,892 dropouts were selected for this study. Then, we used these 1,892 learners' clickstream data to build the collective attention network and use flow distance, a metric, to calculate the probability that attention would flow in or out of a learning resource. After that, we use one of minimum spanning tree algorithms to generate the skeleton of the network, which shows the learning pattern of dropouts. Such a tree, representing the topological properties of the collective attention network, yields a lower bound on the cost of collective attention. As we argued before, MOOC learning is pricey at the cost of the learner's attention. Thus, this topological structure of such a tree contributes to the design of cost-effective learning resources to prevent learners from becoming overloaded. Guess what we found? First, it can be found that the size of nodes belonging to Unit 1 is the largest, while the size of node 13.01, the exam, is the smallest. That is, the visiting pattern of dropouts presents a long-tail distribution. This illustrates that the amount of attention flow decreases from earlier units to later units. However, the largest node 1.01, which the most of collective attention flows in and out, is not the center of this minimum spanning tree. Instead, the exam unit, 13.01, is the distinct center of the minimum spanning tree. It implies that the cost of collective attention is minimum by giving the assessment a central role to connect with other learning resources. We can also see In this tree, a separation of the learning resources into 3 large branches of resources and several twigs of varied lengths. It is interesting to note that quizzes are likely to be at the crossing of the main branches. We guess quizzes are not used by dropouts to evaluate their studies. Instead, dropouts use quizzes as a learning strategy to guide their study. This preliminary exploration of how dropouts learn in a selected MOOC only sheds light on behavior patterns using the model of collective attention and its minimum spanning tree. If you want to learn more details, please see our work. If you have any questions or suggestions about our work, please feel free to contact us by following emails. Thank you.